Please subscribe Vishwas Easy Learning channel and press bell icon.
Welcome you all in Vishwas Easy Learning Academy. I am Shantanu Deshmukh and today we are going to see physics. Today our main topic is gravitational force, but for that we have to know first of all types of fundamental forces and which are them. The first fundamental force is strong nuclear force. Second fundamental force is weak nuclear force, and these both forces are interrelated with each other. Third fundamental force is gravitational force, and the last one is electromagnetic force is the last fundamental force. Now we will see the brief description of gravitational force. What is meant by gravitational force? If we are thinking about two bodies, let's see this. If these are two bodies, this pen is first body and this pen is another body. According to gravitational force, these bodies attract each other towards each other. Means they are exerting gravitational force on every another body. According to the gravitational law, it states that every particle of matter in the universe attracts every other particle with a force which is directly proportional to the product of masses of particles. Means this is m1 means first particle and this is m2 means our second particle. Means m1 is the mass of first particle and m2 is the mass of second particle, and it is also indirectly proportional to the square of the distance between them. Means here r is the distance between first particle to second particle, and r square means the square of that distance. So here we can write it as F is directly proportional to the product of masses, means m1 into m2, and inversely proportional to the square of the distance between them, means r square. Here this is the proportionality constant sign, and if we are going to make proportionality constant into equal to, means we must have to take some kind of universal constant, and here we are seeing gravitational force. So we are taking universal gravitational constant. So here our G is universal gravitational constant, and anywhere in the universe the value of G is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. The dimension of universal gravitational constant is m power minus 1, L power 3 and T power minus 2. Now we will see the next topic of gravitation, that is gravity. In case of two gravitationally interacting masses, if one is earth, then the gravitational force is called as gravity. Means we are seeing that we are attracted towards the surface of the earth. Actually we are not attracting towards the surface of the earth, it is attracting towards the center of the earth, and it is happening because of acceleration due to gravity. But for that we have to know what is meant by gravity. So now you can get that in case of two gravitationally interacting masses, means if two bodies having gravitational force and it is attracting towards each other by means of gravitational force, then in that case if one body, one mass is earth, then that force is called as gravity, and it is denoted by small g. We will see it laterwards. Now we will see the acceleration due to gravity. The acceleration produced in the motion of two particles, means the acceleration produced in the motion of a body under the gravity is known as acceleration due to gravity. Means we see that if we are plucking this pen at this height from the earth, and if we are releasing it, then it can down to the earth. How it is possible? It is because of acceleration due to gravity or by means of gravity. So what is meant by acceleration due to gravity? If this pen is plucking down, means it has some kind of motion, and that motion is known as acceleration due to gravity, and it is denoted by small g. Now we will see it, is it a vector quantity or is it a scalar quantity? But it is a vector quantity, because acceleration due to gravity has some kind of quantity, means some kind of magnitude, as well as it has direction. How its direction can be calculated? Because its direction is always towards the center of the earth, means its direction is definite. so it is called as vector quantity. Now if we are looking towards its magnitude, and it is calculated as 9.81, it is calculated as 9.81 meter per second square on the earth surface, but it will change according to, if we are going to change the planet, then its acceleration due to gravity must be changed. Now we will see how to calculate the value of g, means small g means value of acceleration due to gravity. Here we have taken two bodies, one is the earth and another is the particle which is falling on the earth surface, means it is attracted towards the center of the earth surface due to acceleration due to gravity, or we can say that gravitational force. Here we have taken Fg. Fg means gravitational force. It is because of acceleration due to gravity, so we have taken it as small g also. We can take it. Now h is the height of the small particle from the earth surface and r is the radius of the earth. So the initial position of the particle from the center of the earth is taken it as r plus h. Now mass of the earth is taken as capital M. Mass of the particle which is falling on the earth surface is taken as small m. Now we will see its calculation. Now what is the formula for force? In general terms, mass into acceleration, but here our force means gravitational force which is acting on the small particle from the surface of the earth or from the earth particle. So we have taken it as Fg means gravitational force is equal to mass means mass of the small particle which is falling on the earth surface, so it taken as it is. And now acceleration. Acceleration means acceleration performed by the body which is falling on the earth surface during its motion. So we have taken it as small g means acceleration due to gravity. We can write it as g suffix a for understanding. Now we will again simplify what is the formula for gravitational force. Capital G means universal gravitational constant into mass of the first particle into mass of the second particle, means g into m. M stands for what? Mass of the first particle means mass of the earth, capital M. Small m means what? Mass of the particle which is falling on the earth, means mass of the second particle. Gravitational force is inversely proportional to the square of the distance between the two particles. Here the distance between the first particle to center of the second particle means center of the earth is h plus r, means r plus h we can take it as. So we have written here as r plus h square is equal to m into g will be as it is. Now we will simplify it as again. Here m comes and on the right hand side also m comes, so we can cancel it out. So in next step we will have g is equal to capital G into capital M, means only mass of the earth will matter here, means we can say that the acceleration due to gravity of any planet is depend on the mass of that planet. It does not depend on the body which is falling on that planet. Here we are seeing about the earth's gravitational acceleration, means acceleration due to gravity due to earth surface. So here our capital M is the mass of the earth, and now we will see it here why I have taken it as only r. The radius of the earth is I have written it here, r is equal to 6.4 into 10 raised to the power 6 meter, means it is so much bigger in front of h, means if I am tilting the pen down, means it is falling on the earth surface after releasing it. So what is the height of this pen? It is very negligible in front of the value of capital R. So we have the term that h is smaller than r. That is, we can write it as r plus h is nearly equal to capital R. So I have taken it only capital R due to this expression. Now we will put the value of these things, so we can get the value of small g. What is the value of capital G? 6.67 into 10 raised to the power minus 11 And then what is the value of capital M? I have written it as here, 6 into 10 raised to the power 24 kg. Always remember one thing, the mass of the earth will never change, and the radius of earth will also never change. So I have written it here because it is also a constant term, we can say that, as it is the value of universal gravitational constant. So we have also put here the value of capital M, 6 into 10 raised to the power 24, and in the denominator we have taken the square of the radius of the earth instead of the total distance between the particle which is falling on the earth. So what is the radius of the earth? I have written it as here, as I before, 6.4 into 10 raised to the power 6 meter. So I have taken it here in the term of square. So after calculating this expression, which value we will get? 9.81 meter per second square. Now we will see the basic numerical on the gravitational force. We have given here three quantities, m1, m2 means mass of first particle, mass of second particle, and the total distance between these two particles. m1 is given here as 1 kg, m2 is given here as 2 kg, and the total distance is given here as 50 centimeter. I am stressing here that is 50 centimeter. As it is not given in MKS unit system, we will have to convert it into MKS unit system. So we have converted here from 50 centimeter to 0.5 meter. Now we will put all this value in our gravitational force formula. G stands for 6.67 into 10 raised to the power minus 11, m1 stands for 1, m2 stands for 2 kg means 2, r stands for 0.5 meter as we have calculated it before, that is 0.5 square. Now in next simplified step, 6.67 into 10 raised to the power minus 11, 1 into 2 means 2, and 0.5, here 1 by 2 is equal to 0.5, means we can take 0.5 as 1 by 2 square. So our next simplified step will become this, and as 1 by 2 square is in the denominator, if we will take this into numerator from denominator, then its reciprocal will come in next simplified step. So our next simplified step is 6.67 into 10 raised to the power minus 11 into 2 into 4, and after solving this quantity we will get our final expression, means our value of the gravitational force, that will come 5.33 into 10 raised to the power minus 10 Newton, and Newton is the SI unit for all kind of forces. So we have given their SI unit, that is Newton. If you like today's content, then please like, share and subscribe our channel, and if you have any queries or doubts regarding today's section, then you can comment.